So what we're going to do now is we're going to implement pagination in our application. And what we really mean by this, if I go to our user repository and we take a look at what we're going to be paging, then it's going to be these users here where we're getting our members. Then this is what we want to page. And what this means is we add things like the take on here and we specify how many users do we want to take. And we might say 5, and we might want to skip the first 5 or whatever, for instance. But we're not going to do it inside each individual method like this, because this would be inefficient and we'd have to do the same for each different repository that we add. And every time we wanted to return a list, we want something a bit more reusable than doing it directly inside this method. So what we'll do is we'll start off in our helpers folder, and what we're going to create is a new class and we're going to call it paged list. And what we're going to do with this is we're going to make it generic. We're going to say it can take any type of entity. And that's what we mean when we specify a type. We're going to say, yep, we're going to have a type in here. And T could be our member DTO, for instance. And it gets swapped at compile time depending on what we use with our page list. And our page list is going to be a type of list. So what we're going to do is inherit from the list that we get from systems collections generic. And our list also takes a type parameter and we'll make it the same. A list of T, which could mean a list of users, a list of members, etc. So what we want inside our page list is some paging properties. So we're going to have a property for the current page, and we'll have a property for the total number of pages called total pages, and we'll have a property for the page size, all ints, and we'll have a property for the total count. How many items are in this query? Now this could be all of our users and we don't do any paging, or it could be based on our query. Let's say we just wanted to get all the female users, then it would be how many total female users are available. And that's what goes in the total count, and we work out the total pages and which page we're on and how big the page is as well. So what we need for this is a constructor. So we'll put our mouse or a cursor inside the page list, and what we want here is to generate the constructor ... and this gives us a starting place for what we want to do. So inside this page list constructor, we're going to pass in the items that we get from our query. And this is going to be of type IEnumerable, and it's going to be of type T because it could be anything, and we're going to say items. And then we'll have an int for the count, and then we'll have an int for the page number, and then we'll specify the page size, and we'll remove the total count here, and we'll just use the count property inside our constructor. And we're going to set the current page equal to page number. We're going to set the total pages, and we need to calculate this based on how many results there are. So this is going to be an int, so we're going to cast it to an int, and then we're going to say math, and we need to bring in system to use the math class, and then we're going to specify ceiling. And what we want to do here is get the count divided by, and then we use double, and then we specify the page size. So what we're saying is if we've got a total count of 10 and our page size is 5, then we're going to work out that we've got 2 pages from this query. If we had a count of 9, then we're going to work out count of 9 divided by page size, which would be 4.5, but we're going to go to the ceiling and make that an integer, so that would still work out as 2 pages. And then what we'll do is keep the page size as it is, and the total count we're just going to set to count. And what we also want to do in here is add the range of the items inside this constructor. So what we'll do is we'll add range and specify items inside here so that we have access to these items inside our page list. Now what we're also going to do in this class is we're going to create a static method that we can call from anywhere. So what we'll do is we'll say public static async, and this is going to return a task of our page list of type whatever this is. And then we're going to say create async, And what we're going to pass into this is an iQueryable, because this is going to receive our query where we work out the pagination information, predicate we're using for a where clause, for instance. We're going to have an iQueryable that we're going to pass into this. And we'll see how this works as we build it out. So don't worry too much about what we're doing just now. And our iQueryable, again, is going to be a type of T, because this could be anything. It could be our users, it could be our messages. We're going to want to use this for anything we want, really. And we'll call this source. This is going to be the source data. And we'll pass into this the page number and the int of the page size. And inside this method, let's bring this down so that nothing gets left off the screen. Inside this method, what we'll do first of all is we'll work out the count. How many items are there from this query? So what we'll do is we'll say var count equals await and then source dot count async. And we'll need to bring in Microsoft Entity Framework Core to use the async version of count. Now this does make a database call. This is unavoidable. If we want to work out the total number of records that we're going to return, we have to use this count, because what we get back from the database is not going to equal what the total count of available items is. So there's no avoiding making two separate queries from this. Then what we'll do is we'll specify var items equals await, and then we'll say source. And what we want to do is skip over a certain number of records, and we need to calculate this as well. And what we're saying here is we want to skip over the page number -1 multiplied by the page size. And then we're going to take the page size, and then we're going to execute our query by using toListAsync. So if we're on page number 1, for instance, then we say page number 1 or page number -1 gives us 0 times by the page size, which could be 5. Then we're going to say we're going to skip no records, and we're going to take, let's say, 5, for example. If we were on page number 2, then we would -1 to make it 1 times by the page size, which could be 5, and then we're going to take 5. So then we'll be on the second page of the next 5 records. And what we want to do after this is we want to say return, and we're going to say new paged list of type T, and we're going to say items, and we're going to pass back the count and the page number and the page size. And I'm getting an error because I'm probably missing system threading tasks, and we need to bring that in as well. So this looks a little bit strange for a class, because we've got a static method inside here that then goes ahead and effectively creates a new instance of this class that we then return that contains all of these properties. And that's what we're doing with this add range. We want to add the items into this class so that when we do create a new instance of this, which we do by using this method, we're creating a new instance of our page list class because that's what we're returning. And then we work out the counts, we work out the items that we're going to be returning based on the page number and the page size, and then we return a new instance of the page list with all of this information inside, which matches our constructor, what we're doing here. So bear with me with this whilst we go and set up the rest of the helper classes we need. And what we'll take a look at next is adding a helper class so that we can add this information into our response when we send back the response.